So we've been talking about loops. We've been talking about the different parts of the loop, the update expression, the control variable. One thing that is possible to do, although it's not commonly done, is to have multiple initializations, compound conditions, and multiple updates within a single for loop. So here's an example of what that might look like. Here we have two variables. We have a for loop with the variable I declared within the loop, and it's initialized to 5. Then the variable j is also declared here, and that one's initialized to 0. Note that there's a comma in between, not a semicolon. We do use a semicolon to start the next section. In other words, in between the initialization section and the condition section, there is a semicolon. This condition is uses the OR conditional operator. So if either one of these is true, then the entire condition becomes true, and so the loop repeats. Then we have two updates. So each time this loop repeats, the variable I is incremented by 1, and the variable j is incremented by 2. So both of those things happen in this for loop. So there's lots of variations you can do with this. I'm sure you can imagine that this could get pretty complex. But again, this is typically not done. Typically with a for loop, there's only one counter variable and only one update statement. But I'm just showing you that it is legal to include more than that. Then on the other extreme, you can have a very minimal for loop. So this has no initialization, no condition, and no update. It just has a couple of semicolons. And that is a legal for loop. But what do you think this loop will do? It'll be infinite. There's no condition to make it false. So again, not typically done in the real world, but technically you can do it. A common application of loops is to calculate a running total. So in other words, there's a accumulation variable, if you want to call it that, that keeps adding values to itself, becoming bigger and bigger, keeping track of some sum. So here's an example of that with total sales.java. Let's take a look at what's in here. We have the decimal format class being imported, as well as the JOption pane class. Those should look familiar to us. We need the JOption pane for dialog boxes. We need the decimal format class to be able to format as a decimal, and it's used down here. We have some variables. Days is an int. Sales and total sales are doubles, and input is a string. So we ask the question for how many days you have sales figures, and we input that into this variable days. Total sales is initialized at 0. That's actually very important for the accumulator. We have to initialize the value so that it knows where to start. So we need to initialize that to 0. Here's our for loop. Variable count is initialized to 1, and we'll repeat as long as count is less than or equal to days. And remember, days was retrieved from the user, and count increments by 1. Then we display a message that says enter the sales for that day. We input that number into this variable called sales, and here's the accumulator, total sales plus equals sales. And what is that symbol shorthand for again? That plus equals, what does that mean? Add the number to itself, basically. So this is, in this example, it would be shorthand for total sales equals total sales plus sales. So we'd evaluate total sales plus sales, then add that sum to total sales. So total sales keeps accumulating the sales for each day. So let's go ahead and run this. The computer is very slow today. Wow.
The classes just opened up to sign up for, so there might be a lot of.
Oh, is that what's going on? There's a lot of network traffic?
Yeah.
Huh. This is really slow. I might have to come up with a backup here. Let me think. Oh, there it is. There's a dialog box. Sorry. So how many days? Let's say 5 days. We'll enter the sales for day 1, 2, 4, 3, 6. I'm just making up numbers, and it calculates the total, $20. Now, why is count, the variable count, initialized to 1? Why not 0? Say that again? Okay. So why does it need to be 1 and not, what would happen if it was 0? Right. You'd get 1 more than the number of days that the person requested. So that's just another example of what can happen with an off by 1 error. So you want to be careful of those. So in this case, since these two things have to be correct together. So count is 1, and also we're going to loop while count is less than or equal to days. Okay, so those two things working together will loop the correct number of times. If we changed this to 0, then it would loop 1 more time than what we intended. Whereas if we changed this to say less than instead of less than or equal to, then it would loop 1 less time than what we intended. Okay, so you want to watch for those off by 1 errors. Any other questions on this example? All right, good. Here's what that program might look like as a data flow diagram, the logic behind this program. So we have our accumulator, which, as I mentioned, needs to be initialized to 0. Then we have our conditional statement right here. And as long as that's true, we go ahead and execute these statements and come back and ask the same question again. And then that will repeat as long as the statement is true. Once it becomes false, then we move on to the next part of the program. Now, there are some situations in which we don't know ahead of time how many data points we need to enter. In those situations, a common solution is to use what's known as a sentinel value. A sentinel value is some value that is outside of the acceptable range of the data that the user is inputting. So a common example is to use -1 as a sentinel value for data that can only be positive. So in the example we're about to look at, we're collecting the points in soccer games, and those values can only be positive. So we're going to tell the user that -1 is the sentinel value. So if they type -1 as a score, instead of adding that score to the total, it will end the program. So let's go ahead and look at that example. So we're using the scanner object. Then we have this new scanner, so we're going to be getting data from the keyboard. We have these two variables of type int, both initialized to 0. Now we're giving the instructions to the user. We're telling them to enter the number of points for each game and then -1 when finished. And that's important. We need to tell the user what the sentinel value is. Okay, otherwise they wouldn't know how to end the program. They'd be stuck in an infinite loop possibly. So then again, we tell the user enter game points or -1 to end. We get that from the user stored in points. And then while points is greater than or equal to 0, we're going to add points and accumulate that in total points. And this will keep repeating until the user types -1. Or actually, in this case, what else could they type to end the program, the way this was written? -1 will end the program. What else would end the program? Any negative number would end the program, because this is written as points greater than or equal to 0. Okay? So let's go ahead and run this. So here we'll enter some points. When we're done, we'll type a negative number, and there's the total. And just to show that we actually wrote this so that any negative number would end the program. There it is. Okay, any questions on that? What if we wanted to change it so that only -1 ends the program? Say that again? Well, it's greater than -1 and not 0. That's the same thing logically as what we have, I think. Oh, but okay, it doesn't include 0. But the question is, we want to rewrite this so that only -1 ends the program. Any other number would cause it to keep running. Right, yep, not equal to. That's what I was looking for. So if it's written this way, you can type some negative numbers and get added to the score. I have a 0. All right, so 0 ends the program. We make that -1. Get the idea. Which do you think is better? To make it so that only -1 ends the program, or any negative number ends the program? I would tend to agree, any negative number, because in this case, if we're talking about points in a soccer game, a negative number doesn't make sense. So yeah, I would go with a negative number. So we can put that back. All right. We already talked about nested loops. We did an example with nested loops. Remember, a nested loop is one loop inside of another loop. In this example, the internal loop using the j variable repeats 10 times. The external loop repeats 10 times, but since the internal loop is inside of the external loop, it repeats 10 times for every time that the external loop repeats. So the end result is that these statements here would get executed 100 times. There's lots of things we can do with nested loops. Here's an example called clock.java. So in this program, we have nested loops 3 levels deep. The internal loop accumulates seconds. When it gets to 59, that ends the seconds loop and it causes the minutes loop to go to the next value. And the seconds loop starts over, and so on. And when the minutes loop gets to 59, that causes the hours loop to increment, and so on. So this is currently obviously running faster than real seconds. We could modify it so that it was actually accurate. It actually displayed the values 1 every second. And that wouldn't be too far from being a usable application that you might be able to put on, Google Play and have someone install on their Android device. Remember that you can write Android apps in Java, and there's lots of apps out there for stopwatches. So this is pretty close to that. Any questions on that example? No? Okay. Now the break statement is something we've seen before. Where have we seen this before? Right, the switch case statement. Remember that? So we had the keyword switch and some variable, and then we had several cases. Depending on the value of the variable, a particular case got executed. And then to end the case, we used the break statement. Now, while the break statement is good syntax in the case switch statement, the break statement is considered bad form for a loop, but you can use it. So you can use the word break to end a loop. I don't recommend that. Instead, use the native condition statements that are part of the loop. And the opposite of the break statement is the continue statement. So you can use this to cause the loop to continue back where it left off. Again, it's considered bad form. It's available, but I don't recommend it. Write the loops so that they use their native conditional statements to determine when to stop. So we've looked at three main types of loops: the while loop, the do while loop, the for loop. And it's important to understand the characteristics of each of these loops so that when you're presented with a problem, you know which loop to choose. So to recap, the while loop is a pretest loop. So you want to use the while loop if there's a situation in which the statements may not execute at all. So if the condition is false the first time, then the statements in the loop will not get executed at all. And there are situations in which that is what you want. Next, we have the do while loop, which is a post-test loop. You want to use this loop when you want the statements to execute at least one time. So since the condition in the do while loop isn't checked until after the statements have run, you know that the statements will run at least once. Finally, we have the for loop, which is also a pretest loop. And this is to be used when you know exactly how many times you want the loop to repeat. Questions on those? Good. Moving right along then to file input and output. It is possible in Java and many other programming languages to actually write data directly to a file as opposed to the screen, which is what we've been doing so far. Typically, these are going to be text files. And let's see how we do that. So we need the print writer class. We need to create a new object of type print writer. It does require one argument, which is going to be the name of the file that we're writing to. We can use the print statements and the print line statements, which we're already familiar with from the system.out object, but they're also available with the print writer object. So here's what that might look like. We've created a print writer object. We've named it output file, and we've given it a value of names.txt. So that's going to be the name of the file. To put some data in the file, some contents in the file, we use the name of the print writer object and print line. Then we give it the string or the number that we want to write to the file. We can do this as many times as we like. And then we need to make sure to close the file. Otherwise, other programs may not have access to the file. We do need to import the print writer class, which is part of the IO group of classes. So let's look at an example, file write demo.java, that uses this. So we're importing scanner, we're importing java.io.star. So we need that for input and output. In other words, for reading and writing from files. We have some variables. File name is a string, friend name is a string, num friends is an int. We're going to ask the user how many friends they have, store that in num friends. Then we're going to get the names. First, we're going to get the name of the file. Then we're going to have a loop that's going to count from 1 to however many friends the user specified, ask for the name of that friend, and write that name to the file. Okay, let's go ahead and try it. Now I really do have more than 3 friends, but in the interest of time, I'm just going to put 3. What do you want to name the file? Friends. I used that name in a previous class, so I'm going to name it friends2.txt because it's going to be a text file. And we're going to give it some names. Okay, so the data is written to the file. And we can see it by using Windows Explorer and opening the file. Now, it's going to be written in the same place where the Java file was running. Okay, unless we specify otherwise, it's going to write it in the same directory. So we can go ahead and browse to that directory. And there it is. Okay. Any questions on that example? Pretty straightforward. Good. Now there's this thing called an exception in Java, and that's what happens when the Java program is unable to finish what you've asked it to finish. A pretty common example of that is if we ask it to open a file, but the file doesn't exist. So we actually need to throw an exception in that case, and Java requires us to put some code in to handle that. It's pretty simple. So next to our best friend line, okay, public static void main strings args, we just add these 2 words next to it, throws IO exception. And that's actually required if we're going to try to read from a file. So let's look at an example that reads from a file. The example is, I had a few slides here. Read first line.java. So this program, so there's our throws IO exception. It asks us for the name of a file, and then it tries to read the first line of data from that file and displays it to the screen. So I happen to know that there's a file in this directory called friends2.txt, and there's the first line of that file. Now, if we took these 2 words out, this throws exception command doesn't even compile. Okay, it's required in order to be able to read from a file. So it has to be there. And if we give it the name of a file that doesn't exist, that's when we get the IO exception error. And it doesn't have to be a text file, by the way. We can use another file as long as there's text in the file. So for example, I could pick a Java file and it read the first line of the file. Okay, start of a comment, but you get the idea. Okay, so that covers reading data from a file. We can also detect the end of a file. And the way to do that is with this hasNext method. So what this does is it looks ahead in the file to see if there's more data there to read in or not. And if there is, then we go ahead and read it as shown here. And if there's not, then we end the loop and close the file. Now, if we didn't do this, if we didn't check to see if there's more data with this has next method, then we might get some sort of error message because it would try to read in another line of data and it's not there. So let's look at an example, file read. So this is similar to the program we just saw, except in this case, we're using a loop to read the entire contents of the file. So in this example, there's the entire file, friends2.txt, and we could pick any Java file or any file, really anywhere on the hard drive if we wanted to get fancy by specifying the path, but I'll just stick to this directory. There it read the contents of that file, displayed the entire program to the console. Yes? To specify path, you need to use slashes. It's in here somewhere. No, right. So if we want to specify somewhere on the root of your hard drive, then you would use C://. Now this example uses A. You guys may be too young to remember this, but computers used to have floppy drives. You guys know what those are? Okay, so typically the floppy drive was designated as the A drive on the computer. So if you had a file on the floppy drive, you would start it as A://. Now on modern computers, they typically don't come with floppy drives anymore. So for whatever reason, the standard way of naming the main hard drive is with C. So C:// is how you would get to the root of your hard drive. Then from there, you could specify a file name, or you could specify a path by listing the directories with the slashes in between, and then the file name at the end. So by using those paths and slashes, you can get to any file on the hard drive. And if you need to go up a directory, you would use 2 dots. So in other words, if we were, say, in this directory, R Harrison, but we needed to get to the home directory, the syntax for that would be a dot and then a // here. So it would be dot. Can you see that? Dot // and that would go up a directory. Okay? Does that answer your question?
So how do you get inside of the file that the program's running in? Like, so say it has a file
In the same directory that it's running in?
like within the same directory that's running in it. There's a folder or something.
Oh, if there was a folder in that directory, then you would start with the name of the folder, and then a / and then the name of the file, or another folder. So you would just start with the name of the folder, then a / and then go on from there.
So it just assumes that you're starting it.
Yes, by default, it assumes you're starting in the location that the Java program is running from. And that concept of paths, absolute paths versus relative paths, is actually really important in web programming. So if you want to get more into web programming, that's really important to understand these paths. So this is a relative path because it starts from the current location and goes from there. Whereas the one we looked at on the previous slide, this is an absolute path. It goes to the root, to the A drive. And the equivalent of an absolute path on the World Wide Web would be something like, there's got to be a type here. Well, it'd be something like this: H T T P colon slash slash, right? You've probably all seen that. And then www dot whatever, that would be an absolute path on the web. So that's what you would use if you were going to have a link to someone else's website. If you wanted to have a link to within your own website or make an image show up within your own website, then you would use a relative path, something like this. Okay? All right, one more topic, and that's random numbers. What's a random number? No? Thanks. You can't define a word with a word. It's a number that you don't know what it's going to be, basically. Right? So some real world examples of random numbers. If you have a six-sided die and you roll it, you know it's going to be a number between 1 and 6, but you don't know which one. That's a random number. If you flip a coin, you know it's either going to be heads or tails. You could assign those to numbers, 0 or 1 or something. That would be a random number. So most programming languages provide a way to generate random numbers. In Java, we need the random class, and the syntax is we use the keyword random from the random class. We give it a name and make it a new object of type random. Typically, when we generate a random number, we need to convert it to a data type, and we've seen how to do that already with things like next double, next float. And a little new tidbit here, the next int method can take an argument. It doesn't require an argument, but it can take an argument. If we give it an argument, then it's going to specify a range which the number will be rounded to. And the range will be 0 to actually n minus 1. So let's look at an example to demonstrate what that means. So we're importing the scanner out, the scanner class and the random class. We have a string that we're going to use to determine if we're going to roll the dice again. And we have two die 1 and die 2. They're both integers. We're creating this new object of type random. And here's the key line here. Die 1 is equal to rand dot next int parentheses 6 plus 1. So what that does, this part rand dot next int will generate a whole number between 0 and 5, including 0 and 5. Then to make it in the range that we want, which is between 1 and 6, we need to add 1 to it. Okay, same thing happens for die 2. Then down here we display the two values, and here we display the sum of the two values. So we're basically simulating the rolling of two six-sided die, which is common in lots of board games. So let's go ahead and run this. So it rolled for the first time, it rolled a 6 and a 6, said the sum is 12. Roll them again, yes. That's actually very unusual to get that for the first roll, right? 6 and a 6. Anyway, roll them again. 1 and a 1. Oh, wow, we got the other extreme. I promise this isn't rigged. Okay, now it looks like it's rigged. It's really not, honestly. So there's a 4 and a 5, add up to 9. 6 and 5, 11. And you get the idea. Okay, so you could use this to play, online Monopoly or something. Now, question. So we've established that this program simulates the rolling of two six-sided die and adds them together. Now we know that the range of adding two six-sided die is between 2 and 12, whole numbers only, right? So can we just use a single random number generator and generate a random number between 2 and 12. Would that be the same thing? You're on the right track. The odds of what exactly? Right. So the general idea is that if we're adding the sum of two six-sided die, there are some numbers that are going to be more common than others from a probability point of view. The most common number, probabilistically, is going to be 7, because there's lots of different ways to add up to 7. You can have a 6 and a 1, 5 and a 2, 4 and a 3, then 3 and a 4, 2 and a 5, 1 and 6, and so on. So 7 is going to be the most common roll. As we move away from 7, the values are less common, less frequent. And the least frequent being 2 and 12, because there's only one way to get those numbers. You have to either roll a 1 and a 1 to get a 2, or a 6 and a 6 to get a 12. So very good. At the end of the day, they would not be the same thing. So that's one of your jobs as a programmer, is to understand that not all random numbers are equally random, is basically the moral of the story there. Okay, we have about 5 minutes left. I have a little project we're going to start today and finish up tomorrow. I'm going to give you the choice to either work in groups or work alone. Who would prefer to work in a group? A few people? Okay, we'll do groups. So how many people are here? 1, 2, 3, 4, 5. There's 15 people, so we'll do 5 groups of 3. So count off by 5s, starting over here. 1, 2, 3, 4, 4. We're doing 5 groups of 3. You're 4, 5, 1, 2, 3, 4, 4, 5, 1, 2, 3, 4, and 5. All right, so find your group members, get together. Here's the assignment. What you're going to do is first learn how to count to 5. Just kidding. We're going to write a program that will prompt the user the number of times to roll 2 6-sided die. And then write the results to a file. And also prompt the user for the file name. So basically everything we learned today all put together in one exercise. Okay? Get to it. You've got 4 minutes. Get started. Save your work. We'll finish it tomorrow.
Do you want us all to work on our own?
No, work in the groups.
No, I mean, write one on program.
Yeah, write a program. One program per group.